Okay, we stopped here in Ohm's law. So when the temperature of a conductor remains constant, the current passing through the conductor is directly proportional to the potential difference across it. That is, at constant temperature, I is directly proportional to the voltage. Therefore, V over I is a constant. This constant is known as the electrical resistance of the conductor. The unit for measuring the resistance is the ohm, that is V over I equal to R, where R is resistance of the conductor. So I is the current, V is the voltage, and this R is the resistance. So this is the law which is found by this George Simon Ohm. The unit for measuring the resistance is ohm. So the instrument is ohm meter. We came to here, so you could see that always when you divide this voltage from I, that means V over I, this gives a constant value. If a graph is plotted using your data with the voltage difference in the y-axis and the current in x-axis, it will take the form shown by figure 19.18, the way that current varies with the potential difference. So the first example is, so you have this equation right now. This is the equation. See, this is the equation. So you should know this equation, and you are getting here, this is the equation, V equal IR. Then you are getting, because when you put this I into this side, it becomes V equal IR. Okay, then this equation is what you are going to use in upcoming all questions calculations. Here a current of 1.5 ampere is flowing through a bulb which has a resistance of 6 ohms. So resistance is given by the unit ohm and the current is given by a ampere. Find the potential difference across the bulb. By applying voltage V equal IR for the bulb, VI is given from that SI unit, so it is 1.5, and this R is given from its SI unit, it is 6, so you can just multiply 1.5 from 6 and you are getting the answer 9, and the SI unit of this 9, that means voltage, is volt, it is capital V. So let's see these three exercises. Pause the video and do them. Pause the video right now and do the three questions they have given. After that, after you have done the questions, then continue the video. Then I'm going to solve them right now. So you can have a piece of paper and do them. No need to write the topic and all the things, because I'm going to give you the short note which I have made for this lesson later. Until that, you can do these questions in just a piece of paper. Take a piece of paper and find out the answers. After you find out, then I'm going to solve them right now. I think you are continuing this video after you have solved the questions. Okay, so for the first one, when a bulb is connected to the 12-volt power supply, a current is 0.5, and what is the resistance of the filament of the bulb of that instance? So what you have to do is just write V equal IR, V 12 equal I is 0.5 multiply R. So R equal 12 over 0.5 means what? So this is half, so it becomes 24. What is the symbol? It should be like this. Oh, this is the symbol. So this is the answer. This is the multiplication. Okay. I just put that star mark instead of the multiplication. So R equal 24 ohm. So then as a second question, a nichrome wire coil has a resistance of 10 ohm. A nichrome wire coil has a resistance of 10 ohm. So this is 10 ohm. When it is connected to a power supply, a current of 0.6 ampere flows. What is the potential difference between the terminals of the power supply? So what they are asking here is potential difference, that means the voltage. So we are going to continue writing the equation here. V equal, IR. In the next row we don't have V, that means potential difference. You have the answer for I, it is 0.6, and you have to multiply this one from R means it's 10. So we ended up answer for V, it is 6 volt. Okay, this is the answer for this question, and let's move to the next question. Color of the answers, they should be changed. So in the next question, the resistance of a nichrome wire coil is 6 ohm when it is connected to a power supply of 3 volt. What is the current flowing through it? What you have to do first is write the equation I R. Then in the next row it's 3 volt, no need to write volt, and I, you don't know, it's I, and multiplied from what? Multiplied from 6, no? So in the next row you can write I equal 3 over 6, no? 3 over 6, that means I equal 0.5 ampere. So this is the answer for that question. Okay, so V equal IR, V is 3 and I is here and R is 6, and I, when it comes to I, it means 3 over 6, that means 0.5 amperes. This is how we are going to solve the questions which we are getting from this part. What is the part? Relationship between the current and potential difference. So we are going to use this equation always, B equal IR. This is the equation which we are going to use always, then ended up with that answers. Okay, now the next part, it is factors affecting the resistance of a conductor. Factors affecting the resistance of the conductor. The resistance of a segment of a conductor depends on the following factors. What are the factors? Okay, so this is the fifth part. Resistance. Area of the cross section of the segment of a conductor. This is the first thing which affect the resistance of a conductor. area of the cross section. The second one is length of the segment. Fourth one is material composition. So area of the cross section, length of the segment, material composition. Let us do activity 4 in order to investigate the influence of each of the above factors on resistance. So we are going to check their influence. That means what happened to the resistance if we increase the area, if we decrease the area, and what happened to the resistance if we increase the length, and if we decrease the length, and what happened to the resistance if we use another material. So we are going to check what happened to the resistance with these three factors. So area, length and material. Main words are area, length and material. So activity 19.4 items required is 3 segments of nichrome wire of length 1 meter having different cross-sectional areas, a copper wire segment and several segments of iron wires with the same length as nichrome wires. Okay, what we are going to use? 3 segments of nichrome wire of length 1 meter. So all are nichrome, the same length but different cross-sectional areas. Okay, and a copper wire segment and several segments of iron, a copper wire segment and several segments of iron wires with the same length iron has the nichrome wires and having a cross-sectional area equal to the nichrome wire with the lower cross-sectional area, 2 risers and ammeter, so each those things. Okay, here they have figured out all things which we are going to use here. In the above figure, the number indicate the following segments. 1 means here 1, 2, 3, 4, 5, 6, 7. So you can see these are bulb. This should be ammeter or voltmeter. What is it? They should mention it here. Oh, sorry. Ammeter, yeah, it's an ammeter. So ammeter, battery, ammeter, bulb, switch and conductor wires. The first wire is nichrome wire with the largest cross-sectional area. Nichrome wire with the largest cross-sectional area. Second one is nichrome wire with the medium cross-sectional area. Third one is nichrome wire with the smallest cross-sectional area. Fourth one is different thin copper wire. And fifth one is thin iron wire. So I think it is similar to this nichrome wire. And we are going to check 3 factors now. Here, the largest cross sectional area, medium cross sectional area and smallest cross sectional area. That means 3 cross sectional areas in the same material. And so this is for the first factor. To identify the first factor, remember this area factor, it is for the area factor from the same metal, same conductor, using the same conductor. And for the third one, material composition, the 3 materials here all are same wire, but with different composition. And 6 and 7 is iron wires with unequal length. So this one is for the length factor. Okay, this one is for the length factor. See, Okay, so these are the factors, and we are going to take the observations of this practical and find out what happened to the resistance with those factors. So you have to write down the ammeter reading here. Ammeter reading, that means current, what the amount of current passed through those conductors, you have to write down it. What conclusion can you draw from the readings obtained for the wire 1, 2 and 3? The same wire, the same component, that means same material, nichrome, but with three different cross-sectional areas. What can you conclude from the readings for the wires 3, 4 and 5? Same thing, wires with three materials, and 6, 7. What can you say from the readings for the wires 5, 6 and 7? Means the different length are 5, 6 and 7. 5, the most lengthiest uh, iron wire, and 5, 6 and 7, and 6 is the uh, a medium lengthy one, and 7 one is the shortest one. Okay. According to the activity 4, it will be clear that the current flowing in each of the above instances are different. According to the activity, it will be clear that the current flowing in each of the above instances is different. The reason for this is the differences in the resistance in the each instance. Reason එක මොකක්ද? Differences in the resistance. According to this activity, three main factors that affect the resistance of a conductor can be stated. Okay, we already know them. It's area, length, and material. How each of them affects the resistance is mentioned below. So here we are going to identify it. The resistance decreases when the cross-sectional area is increased. What happened to R decreases when cross increase. When cross increase, resistance decrease. That means resistance means what? What is the meaning of the word term resistance? It is the disturbance. I have told you. So resistance means a kind of disturbance. So when the resistance is increased, what happened to the when the cross sectional area is increased, that means it gives a larger space to pass to those current. That means think like this. There's a pipeline, okay, water flowing pipeline. Then if the area of the pipeline increased, does the large amount of water go through it, or low amount of water go through it? Think about a pipeline, okay, pipeline which allows water to go through it. So see like this, it's a pipeline, so water go through this one. Okay, so tell me, large amount of water, think like I, current is like water. Okay, this pipeline is a conductor. Then this cross sectional area, tell me this I1 is large or this I2 is large. What is large? I1 or I2? වතුරට ගොඩකට යන්න ඉඩ දෙන්නේ කවුද? I1 ද I2 ද? ඒ කියන්නේ sorry. මේ ඔව් වතුර ගොඩක් වෙන්නේ I1 ද වැඩි I2 ද වැඩි? I2 තමයි වැඩි. මෙතන තමයි large amount of water වලට යන්න දෙන්නේ. ඒ වගේම large amount of I කියලා අපි ගත්තේ current එක. ඒතර large amount of current යන්නේ මෙතනදී. ඒ කියන්නේ මෙතනදී resistance වැඩි, මෙතනද resistance වැඩි. මෙතන තමයි රෙසිස්ටන්සි වැඩි. රෙසිස්ටන්සි වැඩි නිසා තමයි අඩු කරන්ට් එකක් යන්නේ. රෙසිස්ටන්සි අඩු නිසා මෙතන ලොකු ඉඩක් තියෙනවා. ඩිස්ටර්බන්ස් එක අඩුයි, රෙසිස්ටන්සි අඩුයි, බාධාව අඩුයි. ඒ නිසා large amount of current යන්න පුළුවන්. ඒතකොට cross sectional area එක මේකේ වැඩි increase වෙලා. ඒතකොට මීට වඩා cross sectional area එක වැඩි වුණාම disturbance එකට මොකද වෙන්නේ? resistance එකට. resistance එක අඩු වෙනවා. මේක තේරුම් නැත්නම් පොඩක් ආපහු චුට්ටක් පස්සට දාලා බලන්න ටිෂි කියලා දෙන කාය අහන්න. එතකොට මේ cross sectional area එක වැඩි වෙනවා කියන්නේ වතුර වලට යන්න තියෙන disturbance එක අඩුයිනේ. එතකොට cross sectional area එක අඩු වෙද්දී resistance අඩු වෙනවා. sorry මේ cross sectional area එක වැඩි වෙද්දී මේ cross sectional area එක වැඩි වෙද්දී resistance අඩු වෙනවා. cross sectional area එක අඩු වෙද්දී resistance වැඩි වෙනවා. මොකද disturbance එක අඩුයි. පොඩි බටයකින් යන්න තියෙන. ඒතර resistance වැඩි. හරිද? ඒතර cross sectional area එක increase වෙද්දී මේ තියෙන area එක increase වෙද්දී resistance මොකද වෙන්නේ? decrease වෙනවා. resistance අඩු වෙනවා. R කියලා ලියා ගන්නම්. R මොකද වෙන්නේ? capital R අඩු වෙනවා. හරිද? ඊට පස්සේ length එක. The resistance increases when the length is increase. length එක වැඩි වෙද්දී හැබැයි වෙනත් එකක් වෙන්නේ. මොකද වෙන්නේ? length එක increase වෙද්දී resistance increase වෙනවා. length එක වැඩි වෙද්දී අයියේ. දැන් හිතන්න length එක වැඩි වෙනවා කියන්නේ මෙයාට ගොඩාක් දුර මේ conductor එක හරහා යන්න තියෙනවා. බල්බ් එකකුත් දාලා කියලා හිතන්න. ඒතර බල්බ් එක පත් වෙන ගොඩාක් දුර ගෙවාගෙන යන්න වෙනවා. හැබැයි ඒතර resistance වැඩි. පොඩි එකක් කියන්නේ length අඩු එකක් short wire එකක් තිබ්බොත් එයාගේ ගොඩක් දුර යන්න නැහැ. ඒ නිසා resistance මොකද වෙන්නේ? resistance අඩුයි. එතකොට length එක වැඩි වෙද්දී resistance වැඩි. length එක අඩු වෙද්දී resistance අඩුයි. හරිද? තමයි length එකට. it's material එක ඒක depend. හරිද? for wires having the same length and same cross sectional area but made of different metals the current flowing for the same potential difference are different. එතකොට ඒක depend. හරිද? එක නා depend. අයන් වල එක ආගයක් වෙන්න පුළුවන්. අයන් වලදී එක කරන්ට් ප්‍රමාණයක් allow කරන්න පුළුවන්. කොපර් වලදී තව එකක්. මේ වගේ වෙනස් වෙනවා. The reason for this is the difference in the factor known as resistivity, because the resistivity of different materials are different. Okay, which depends on the material. So this depends on the material. This totally depends on the material. Resistivity depends on the material. Okay. Then we are going to stop here for this part, and I'm going to discuss the next part, resistance, again. Thank you.